There we go. All right, so welcome to Honors Geometry. This is the first lesson. I believe there is a total of 10 lessons as a part of this. So basically the format for this class will be that every day I'll have a slideshow prepared, and then during the slideshow, I'll give you guys problems that you guys can work on. There'll be problems that I will demonstrate, and then there'll be problems that you guys can work on. And then after a few minutes, say like 5 minutes, after you guys have worked on the problem, you can message it in the chat, and then I'll take a look at it, and then we can go over it. Today it'll probably be a lot of I think it'll be a bit of review, some new stuff, not too much problem solving. This is just kind of getting the basics of geometry down and introducing of you guys to geometry. So today we're just be covering the fundamentals like points, lines, planes, segments, the midpoint and distance formula, the coordinate plane, angles, perimeter, and area. Of course, if you have any questions along the way, just type them in the chat box and I'd be happy to answer them, or you can just unmute and ask me during the lesson. And after each course, I will usually post homework on Classroom. Of course, it is not required. I'm not going to force you to do homework, but it's a good way, I think, of reinforcing what we've learned in class and kind of just going over it and refreshing your memory on it. And also, after you do the homework, of course, you can submit it in Google Classroom, and I'll always take a look at it, grade it, and give you some feedback. And if there's any questions you have while you're working on the homework, you can always message me through Google Classroom. So that's pretty much that. Does anyone have any questions so far on the course, the structure, or anything like that? All right, I do not see any questions, so I'm gonna keep on going. So these are just some warm-up questions. Just for all of these, you're just solving for X, and then afterwards, let me know what you get for the answers. And then when you're done, just message the answers to me in the chat box. Also, if you don't have a pencil or a pen and paper right now would be a good time to get some. You should come to class with pen and paper every class so you can be ready to do problems. So let's just take, let's say, 5 minutes to just go through to you guys do these questions. Of course, if you have any questions while working on these problems, message me in the group chat, message me directly in the chat, or you can just unmute and ask me directly. Uh, Sorry, I just accidentally clicked something in the chat. I just typed the letter, the number 8. You can just ignore that. That's just a typo. All right, we'll just take another 2 minutes or so to work through these questions. Of course, it's completely fine if you don't get through all of them. Just try get done whatever you can get done, and then afterwards we'll just go over them all together. All right, whatever you guys have done, just put your answers into the chat box. You don't need to do have had all of them done. If you just got to, the first one, that's completely fine. Just put whatever you have in the chat box. If you got to, all three, great. If not, that's completely fine. I'm gonna go over it in 1 second. All right, I see some answers in the chat box, so I will go over them now. In 1 moment. All right, let me get this set up. Okay, so for the first one, right, we are solving for x, and so what? So the first thing we want to remember, right, is PEMDAS, the parentheses, exponents, multiplication or division, and then addition or subtraction. There we go. Okay. So first up, right, we have parentheses. So you want to first multiply what we have in the parentheses first. So for the first one, right, we would get 11x plus 6x minus 24, right? You would distribute what the 6 into both numbers, both values in the parentheses, equals 5x minus 108. And then this is, remember this part, when you have the negative, it's negative 12 times 9, and negative, when you multiply negative into it, just remember the sign. So you have negative 108 plus 24x. All right. So once we have this, what do? We combined like values on both sides of the equation. So we combined the 11x and the 6x and the 5x and the 24x on either side, right? So we get 17x minus 24 is equal to 29x minus 108. Now, what do we do from here? We take the like values, right? We put the x's on one side and we put all the real numbers, the integers on the other side, right? So you can really do this either way. You can move the 29 to this side, or you can move the 17 to that side. It really doesn't matter. Both ways are completely fine. For right now, I'm gonna just move the 17 to the other side. So you would get 29x minus 17x is equal to negative 24 plus 108. Is everybody following along so far? Does anyone have any questions on this problem as of now? All right, I'll keep going along. So after this, right, you combine the like values. So you would get 12x on this side, and you would get 84 on this side. Afterwards, you would simplify it, divide both sides by 12, and you would get x is equal to 7. So for the first one, x is equal to 7. Does anyone have any questions on the first problem and how we got the answer? All right, I do not see any questions. I'm gonna erase this stuff so we have room for the other problems. All right, now on to number 2. So for number 2, let me change back. Okay, so for number 2, again, it's the same principle. We want to first distribute the -3 into the parentheses. So what we have is -33x minus 9 equals -3 minus 27x, right? And then afterwards, what do? We take the x's and move them all to one side, and we take the whole numbers, the numbers without an x or a variable, and put them all on the other side. So for this one, I'm gonna move the 37x onto this side, and then the 3 onto this side. So what do we get? We get -9 plus 3 is equal to -27x plus 33x. Afterwards, we simplify. So on this side, we would get -6 is equal to 6. Sorry, that was is equal to 6x. Simplify, divide both sides by 6, and we would get x is equal to -1. Does anyone have any questions on the second problem? All right, I don't see any questions, so I will go on to the last one. All right, so for this one, this is kind of different from the other two. This one, you aren't really solving for x. You aren't solving for like x would equal like 0 or x equals a whole rational number. This one, you're just solving to see what x would be equal to in terms of k, w, and v. So what do we want to do here first? Well, we want to first get rid of the x in the denominator. So how do we do that? We multiply both sides by x. So we multiply this side by x, and we multiply this side by x. But very important, remember that when you're multiplying x on the right side, you put parentheses because you're multiplying x by the entire thing on the right side, not just by w or by v. So now, after we have this, right, we take, so the x and the x cancels out on that side. So all we're left with is k. K equals x times w plus v. All right. And then what do we do from here? We can move the w plus v back onto the other side. So how would we do that? We would divide both sides by w plus v. So this side would cancel out, and you would get k divided by w plus v on this side. So as our final answer, just going to rewrite it neater, x equals k over w plus v. And there we have it. Does anyone have any questions on the last problem? All right, I do not see any questions, so I will keep moving along. Of course, if for some reason right now you don't have a question, but then halfway through the class you're like, shoot, I have a question. I just thought of a question on one of the questions. Doesn't have to be the warm-up questions, and you want to ask it, that's totally fine. You can always just message me in the messages, and I will respond. Get back to you. All right. Next up, we are going to be talking about points. So a point is just a dot on the paper with a letter next to it, usually capitalized. So you would just say this is point A or PTA. The official definition of a point is it has no dimension and it is represented by a dot. This you don't have to write this down. Later on, there are some things that I would recommend that you write down, but for this is just kind of getting to know the vocabulary and getting kind of immersed with geometry vocabulary in a sense. So that's what a point is. Next up, we have a line. So a line, the official definition, a line has one dimension and is represented by a line with arrows on each end and extends with no end. Through any 2 points, there's exactly one line, meaning that the line extends that way towards infinity and that way towards negative infinity. So it goes on forever. There is no end. And you would write this in geometry form as AB, a line AB with the 2 arrows on top, or line BA with the 2 arrows on top. Either one is totally fine. It's more of a personal preference on which order you want to write it in, but you always want to have the 2 arrows on the top. What is it called? Yeah, these 2 arrows on top. This is very important because these 2 denote that it is a line, not something else, not like a segment or array, which we will cover later on in the slideshow. For this, I would highly recommend you guys just write down the notation for the line. Remember, just writing down to remember that it's 2 points like A or B or like C or D. It can be anything, but remembering it has the double arrows on the top. That's what signifies that it is a line. Does anyone have any questions? All right, I will keep on going. So now, this is what I was talking about. This is a segment. This is a part of a line bound by 2 endpoints. So previously we said a line, right? It has no ends. It goes on towards infinity. It goes on forever that way, and it goes on forever that way. But for a segment, right, the reason why it's called a segment is because it has 2 endpoints. It has a start and an end. So that means it has a quantified value. For a line, you can't really say that, say it's like, you can't say a line is 11 meters, right? Because it goes on forever and forever. It's immeasurable. But for a segment, you are able to measure it. And the important part for this, the important takeaway on this part is that the segment, it is denoted by a segment with just a straight bar line. Remember how before it was, for the line, it was with the 2 arrows. Well, for the segment, it's just a straight line. That's something you should remember because when you're doing proofs in the future in geometry, that will tell you if it is a segment or a line. All right. And now we are going on to planes. So a plane, you can either call this plane in the picture either plane M or plane ABC. Either one works. And a plane, the official definition is it has 2 dimensions and is represented by a shape, but it extends without an end. Through any 3 points not on a line, there is exactly one plane. The main takeaway for this is just to remember that you can call it plane ABC or plane M. All right. Next up, we have a ray. This is basically a combination of a segment and a line. So a ray has one endpoint and goes on infinitely in the other direction. And you would symbolize the ray like so with the AB, but a dot on one end and a ray extending onto the other. For the other 2, for the line and the segment, it didn't really matter because it was either a straight line, right, or the double arrow. But for this, you want to be really careful because in the picture, right, you can see that the A is the endpoint and the B is the part where it goes on towards infinity. And so it is represented like that similarly in the picture. If you were to write it like this would be a totally different thing from this, right? They would not equal. Because in this case, this BA with the dot on the B and the arrow on the A, it would signify something like this. All right, so two totally different things. I think rays are one of the things you really have to look out for, and remembering, are you putting the dot on the endpoint on the B or the A or whatever point it is, whichever, just being aware of which one you are putting it on. Right. Next up, we have some other vocab. I would recommend you write some of these down. So collinear means points on the same line. Coplanar means points on the same plane. Intersect is when two or more geometric figures share at least one point. For example, like these two. Let me try 1 second. So say this, right? A and this is segment AB and segment CD, right? You can see that they intersect at this point. We'll just call this point J. So as you can see, they intersect at point J. A postulate is just a rule that is accepted without proof. This will be important when we later on get into proofs in geometry. And congruent just means equal. So for example, if they say AB is congruent to CD, that just means the length of AB is equal to the length of CD. And you would write it like this: AB, you write congruence with the equal sign and then the squiggly line on top. That is how you would show that two segments are congruent to one another. Does anyone have any questions so far? All right, I'll keep on going. Okay. Now this is where we get into the segment addition postulate. First up, I just want you guys to take a look. There should be a little line on top, but unfortunately I cannot get that to type out. But I just want you guys to take a quick minute or two just to find out, what does segment AC, this entire segment, equal, right? If segment AB is equal to 23 units and segment BC is equal to 35 units, what would segment AC equal? Just type your answer in the chat box once you got it. All right, I'll just give everyone else a few more seconds and then I'll talk about this. All right, so this, good job to everyone who got it right. This would be AB plus BC would equal 58. And this is basically what the segment addition postulate is. It's very straightforward. It just means that when two segments are connected by a single point, right? As you can see here, when you add them, they add up to AC. AB plus BC equals AC. That's basically the segment addition postulate. This will be important for proofs again later on in geometry. Geometry is just proofs. And when you're trying to prove, like say, when you're trying to prove that, say this is G, F, and then Z, let's say, right? And this is like 16, and this is 23, and you're trying to prove that it's equal to this line, let's say AB, right? Which is 39. you would have to do something like, GF, segment GF plus segment FZ, right, is equal to segment GZ, which is the segment addition postulates, right? For me, it's fine if you just shorthand it into the segment AD and then P. Some teachers, they'll have you write out the whole thing. Some teachers, they'll just have you shorthand it. But this is basically what you'll use it for later on when you're proving that these two segments add up to one another. It seems very like redundant and rudimentary. Like it seems very logical and very basic. Like, oh, you look at it and it's just 23 plus 35 equals 58. But in geometry, you have to, if you don't prove it, then it isn't true, pretty much. All right, continuing on. Some more definitions is a midpoint, a point that divides a segment into two congruent equal parts. Bisect, to divide a line, angle, or shape into two equal parts. A midpoint bisects a line. The segment bisector is a point, line, or ray that intersects at the midpoint. And then in the picture below, CD is a segment bisector. Let's just take a quick minute or two to just jot down for you guys to jot down your notes on these. You don't have to write them down if you do not want to, but I would highly recommend it. All right. Does anyone need more time writing it down, or are you guys all good? All right, I will keep moving ahead. Next up, we have the midpoint formula. You guys should definitely write this down somewhere in your notebook or on a piece of paper. So this is for finding the coordinate for the midpoint, which is just the average of the x coordinate endpoints and the y coordinate endpoints. So I'll give you guys a quick problem. So let's see, we have 1 second. Let's say we have the point 4, 13, right? And we have the points 7, 19. Can you guys find the midpoint of these 2 points? After you guys find it out, just type it in the chat. All right, we'll just take another half a minute, and then I'll go over it. Oh, thank you for catching that. For this one, it should be x2. I don't know why it says xx. Yeah, that's just a typo. Should be x1 plus x2. All right, let's just take 10 more seconds. All right, so the answer would be 5, 5, comma 16. So of course, how would you get this? You'd plug in the values, so x1 and x2. So x1 would be 4, x2 would be 7, y1 would be 13, y2 would be 19. So you would get 11 over 2, comma 32 over 2, which would simplify down to 5.5 over 5.5, comma 16. For this case, it's fine if you guys simplified 11 over 2 into 5.5, but like in the future, if it's a really ugly fraction like 16 over 3, or like 14 over 5 or something like that, you guys don't have to simplify that. You guys can just leave that in its fraction form. Does anyone have any questions on the midpoint formula? All right. Keep on going. Next up, we have the distance formula. So for this one, this is for finding the distance between 2 points. So this one is x2 minus x1 squared plus y2 minus y1 squared. Of course, you can always have x1 minus x2 squared, right? But when you're doing this, just make sure that you also, for the second one, it's y1 minus y2 squared. It has to match up. So you can do it either way, it doesn't matter, but it has to match up. You can't do x1 minus x2 plus y2 minus y1. That wouldn't work. You have to do it. You either have to put the x1, y1 first, or you have to put the x2, y2 first. So it's either one of those work, but you just have to put them both in the same in front or at the end. And basically, the idea behind the distance formula, right, is the Pythagorean theorem. If you guys have heard of that, it's just the a squared plus b squared equals c squared. It's just finding the hypotenuse basically between the 2 points, because you're finding how many steps you're going in the x, how many steps you're going in the y, squaring them, and then adding them, and then square rooting it. So that's basically where the idea of the distance formula comes from. Okay, let me give you guys a quick problem. So let's say we have 4, comma 5, and then we have 16. And actually, let me erase that. Let's do 10, comma 10. Can you guys find the distance between these 2 points using the distance formula? After you're done, after you have an answer, just plug your answer in, type your answer into the chat box. And for this one, it's fine if you use a calculator to find the square root. Or if you want, you can just leave the answer as a square root. That is also fine. Either one works. All right, we'll just take another minute or so, and then after you guys are done, I will go over the answer. All right, I'll go over the answer now. So for this one, right, we would start off by doing first allocating the x's, right? So let's just say the 10 is x2, y2. This one is x1, y1. All right, so to start off, we have in the equation, let me make that more square rootlet. We have 10 minus 4 squared plus 10 minus 5 squared. Oh, let me get rid of that. Squared. So in this one, you would have 6 squared plus 5 squared, which would get you 36 plus 25 squared, which would give you square root of 61, or about 7.81. Great job to you guys who got it right. Does anyone have any questions on the distance formula? Alrighty. One second while I erase this. All right. Next slide. Okay. So now we are going to talk about perimeter and area. So for starters, guys, can you find the lengths of all the sides? We'll just call this X. We'll just call this side X, side Y, side Z, and side W. Can you guys find the lengths of the sides for me? You guys can, again, you just use the distance formula that we just learned, and you can use that just and plug in the points. All right, we'll take another minute or so. All right. So for this one, the sides would all be 5. All right. So again, I'll just do it for one of them. So let's just take A and D, right? So segment AD would equal the square root of 4 minus, 4 minus 1 squared plus 0 minus 4 squared. This would end up being 9, and this would end up being 16. So we would get the square root of 25, which is equal to 5. And then, as some of you guys noticed, that this is a square. So as in a square, all sides are equal. So all of these sides are 5, 5, 5. And then can you guys find the perimeter and the area of the shape? All right. So for this, the perimeter would be 20 and the area would be 25 square units. So for perimeter, you just add up the lengths of all the sides. So 5 plus 5 plus 5 plus 5 equals 20. And then for the area, you just multiply the length by the width, which conveniently are the same. So you would just do 5 times 5 equals 25. And also, I don't know if you guys have done this yet, but in the future, I'm just gonna write 5 times 5 as 5.5, because when we're dealing with variables and all of those kind of things, it's easy to get it mixed up at times, because you might see this and think it's 5x instead of 5 times. So this way, just know that whenever you see the dot, it's always 5 times a number, or a number times another number. Does anyone have any questions on this stuff? All right. Next up, we have angles. So an angle is made up of two rays that meet at a vertex. That's right here is a vertex pointed in the screen. And then it is either called angle A or angle BAC, as you can see, because the angle is formed by the points B, A, and C in that order, right? And angles are measured in degrees. Oh, there we go. Next, we have the types of angles. So first up, we have an acute angle, which is an angle less than 90 degrees. It would usually look something like this, less than 90 degrees. A right angle, an angle exactly 90 degrees, and it will always be shown with a box right here to signify that it is a right angle. Next up, we have an obtuse angle, an angle between 90 and 180. So an angle something like this. And then a straight angle, an angle that is exactly 180 degrees. Does anyone have any questions on the type of angles? All right, continuing on. Next up, we have some other stuff about angles. So we have congruent angles, two angles that have the same measure. And again, you would show congruency by using the equal sign with the little squiggly line on top. And then the angle addition postulate just says that when you add two angles together, so for example, like BAD, right? You can see right here, BAD and DAC, they add up to BAC. It just means that when you have two angles that make up a larger angle, those two angles will add up to the larger angle. And then an angle bisector is a ray that divides an angle into two angles that are congruent. And usually you will see it mark something like this, like with two lines. When you see that it shows two lines, it usually means that it is congruent. And then, for example, if you have, say, in this, just making up a random shape, say you have something like this, right? If these two base angles were congruent, you would just draw it with the three. So this just shows that these two angles are congruent with each other, while these two angles are congruent with each other. Does anyone have any questions on angle congruency and angle or different postulates? All right, I will keep on going. Oh, okay. Next up, we have some more stuff about angles. I know this first class is a bit more on the boring, more just getting the kind of the fundamentals down. I promise you, the next two classes we will go more into actual geometry. This is just getting all of the vocabulary down, so you know when we're talking about these kind of things, you guys know what we are talking about. So complementary angles, two angles that add up to 90 degrees. For example, like so, right? So you have like A, you have B, you have C, and you have D. So angle ABC and angle BDC are complementary. Supplementary angles, two angles that add up to 180. So like so, right? These two angles add up to 180. And then adjacent angles, two angles that share a common vertex and side. Adjacent angles would look something like this. This isn't 90 degrees, but as you can see, they have the same vertex right here, and they share this common side as shown right here. So that's just what it means by adjacent angles. And non-adjacent angles are just two angles that don't share any common vertices and sides. So for example, it could be like this and this, like angle A, B, C, and angle D, E, F. Right? These two are two non-adjacent angles. All right. Next up, we have a linear pair. So a linear pair is two adjacent angles created by opposite rays and create a supplementary angle. Again, supplementary angle is just an angle that is equal to 180 degrees. So as you can see, angle X Z plus angle Z M Y is equal to 180 degrees. Again, you can write it as XMZ or ZMX. They both mean the same thing, and vice versa. For this one, you can also say YMZ for that one as well. Either one works fine for angles. For the angles, just make sure that M is in the middle because it is the middle point. All right. Does anyone have any questions on linear pairs? All right. And then lastly, we have vertical angles, which are opposite angles formed by intersecting lines. And these vertical angles will always be congruent to one another or equal to one another. So as you can see, XMZ is angle, the measure of XMZ is equal to the measure of WMY, sorry. And then what this little m just means here, it means measure. So when you're just talking about the angle as an angle in a sense, you write angle, but when you're talking about the measure of the angle, meaning in degrees, you always want to write measure. So measure means something like 89 degrees or something like that. Angle, XMZ, it could just mean that it's, congruent. It could mean it's, supplementary, or it can mean it's acute. It means more qualitative, or how do I say this? It's not numerical, I guess. For whenever you put an m in front of it, it means that you're talking about the actual value, the actual degree value. So that's something very important to keep in mind, whether you're talking about the actual measure in degrees, or if you're just talking about if it is congruent or if it is acute, or just something about the angle that is in that doesn't have something to do with degrees. Does anyone have any questions on the last slide? All right. I do not see any questions.